The purpose of this shorty is to show how the string lines are used to set the elevation, or the height above sea level, for the main floor. The layout starts at the reference work point at the corner of the property. Keep in mind that this point both locates the property from a survey monument and marks the known elevation of that work point above sea level. It's therefore a matter of transferring the sea level elevation horizontally from the reference point to the formwork of the raised slab. The general idea is to set up a transit or a survey instrument so that it can read an elevation off a story pole over the work point. The instrument is then pointed to the foundation or some other working point to transfer that elevation to the construction. The pole measurements above the pointed end may be higher or lower than the work point, but the markings on the pole give the relative differences between the two. For example, say the survey gives the sea level elevation of the reference point over here at 34 feet. And say the main floor level for the building is given on the design drawings at 35 feet 6 inches. That means the floor level, the finished floor level of the main floor would be 18 inches higher than the reference point. So if the finished floor tile is say 1 inch thick and the floor slab is 8 inches thick, and the depth of the beam is 14 inches below the bottom of the slab, that would mean the bottom of the beam, which equals the top of the form, needs to be about 5 inches below the reference point. So let me run through those numbers again. Say this tip of the story pole is the same elevation as the working reference point at the corner of the property at 34 feet. And the top of the finished tile, according to the design drawings, is supposed to be 35 feet 6 inches. That means the distance from the transferred reference point elevation to the top of the tile is 18 inches. From that 18 inches, we work down the total thickness of the tile, the slab, and the beam. That's 1 inch for tile, 8 inches for the slab, and 14 inches for the beam. So we have 23 inches down to the bottom of the beam from the top of the floor, which means the difference between this reference elevation and the bottom of the beam is 5 inches. 18 here, 23 down. The challenge is that the top of all of these columns are slightly different. It would also be tough to put a surveyor out on the foundation walls and columns with any degree of accuracy, let alone safety. But there are string lines over the column centers. Keep in mind these string lines have been used throughout the foundation and basement construction in almost the same way that we're going to be using them for the raised slab. So they're a proven reference. So if we use the work point as a sea level reference, and the elevation of the string lines are the same, in other words they're all level, then the top of the horizontal portion of the battledores where the string lines are tied become a known vertical reference. Say the battledores and the string lines are 36 inches higher than the elevation of the reference point. Here's the reference point, string line known to be 36 inches higher. And again, all of these battledores are set to the same elevation. In other words, they're all level. That would mean the bottom of the beam would be 41 inches below the string line, 36 inches down for the height of the string line off of the reference, plus 5 more inches to the bottom of the beam. So since the height of the string line anywhere between the batterboards is the same elevation, the bottom of the beam can be measured as 41 inches below any string line. Note that offset string lines set the dimensions of the formwork. In addition, contractors use GPS, laser level, or water levels to set the height of their formwork. A laser level broadcasts the beam over the construction area, or workers measure down from the beam to the bottom of their form.